Hello friends, welcome to the course Essentials of Data Science with R Software 1, in which we are trying to understand the basic concepts of probability theory and statistical inference, and we are continuing with probability theory concepts. So now you have learned simple probabilities, conditional probabilities, and you also have seen that they have a close relationship with the definition of relative frequency, and that definition is going to help us when we want to compute it through the software. Right. And you can see that simple probability and conditional probability, they are going to be used under different types of condition, but the bottom line is you are the one who is going to take a call whether you want to compute the simple probability or a conditional probability. So now continuing on the same lines, we have one result which is called as multiplication theorem of probabilities. And this helps us that when we are trying to deal with more than one condition, more than one events, and we want to compute a particular type of probability. So in this lecture, I am going to talk about this multiplication theorem of probability, and I will try to take some example through which I can explain you that how the things are going to work. Right. So let us begin our lecture. So now you know that in the last lecture you have done the conditional probability of A given B, which is equal to probability of AB, that is A intersection B divided by probability of B. So this implies that probability of AB is equal to probability of A given B into probability of B. And in case if you try to interchange this probability of A given B by probability of B given A. So this will become here probability of AB upon probability of A, because probability of A intersection B and probability of B intersection A, they are the same thing. So from here you can see here that probability of AB once again comes out to be probability of B given A into probability of A. So now if you try to see both these values, they are the same. So that is what I have written here, that probability of AB is equal to probability of A given B into probability of B is equal to probability of B given A into probability of A. Yeah, and one thing you have to keep in mind that when we try to define the probability or the conditional probability here, you have to assume that this probability of B and probability of here A, they are greater than 0. But when you are trying to define this statement, then you don't need the condition that whether probability of A is greater than 0 and probability of B is greater than 0. But obviously, means in practice you will be always dealing with a case where the probabilities are always going to be greater than 0. Right. So now in case if you try to make this result more general, then how to get it done? This result is trying to express the probability of intersection of two events, that means the probability that A and B occurs together in terms of the conditional probability. So now in case if I try to extend it, that instead of here only two events A and B, suppose we have here a small m number of events A1, A2, Am. Then the probability of A1 intersection A2 intersection Am, how this can be written in terms of this conditional probabilities given different types of condition. So this can be written as probability of A1 into probability of A2 condition on A1, probability of A3 condition on two events A1 and A2, and up to this will continue here up to here probability of Am given A1 A2 dot Am minus 1, right. So now this is actually called as the multiplicative theorem of probability, and this is very useful when you are trying to do different types of computation, although we are not considering here different types of Bayesian computations, but this Bayesian analysis and related Bayesian computation, they are very important nowadays, and this theorem is going to help in those cases. That is why I want to make you understand here. Right. So, now let me try to take here some example to explain you the application of this multiplication theorem of probability. So, the first example which I take here is that a student figures that there is a 30% chance that he will be selected in the cricket team, and if it does, he has 60% chances that he will be selected as the captain of the team. Now, the question is, what is the probability that the student will be the captain in the selected team? That is a very obvious question. This type of incidents will happen in real life very often, and in data sciences also these types of things will happen where you would like to compute such probabilities. And my idea of taking this example is to make a one-to-one correspondence with this example with something which you will be doing as a data scientist in real life. Right. So, in order to solve this problem, let us define here two events. One is here capital T, which is indicating the team, and another here is C, which is indicating the captain. So, let capital T be the event that the student will be selected in the team, and capital C be the event that the student will be made the captain. Now, what you want? You want that the student is selected in the team and the student is made the captain. So, in this case we are interested in the probability of T intersection C. Right. So, now how to obtain it? Probability of T intersection C can be written as probability of T into probability of C condition on the that the student is selected in the team. So, this will be probability of C event T, and now both these probabilities are known to a probability of getting selected into the team is just 30%, which is given here. So, it is 0.3, and the probability that that the student is selected in the team and become the captain, this is 60%. So, this probability is C given T is 0.6 and this comes out to be 0.18. So, there is an 18% chance that the student will be selected as the captain after getting into the team. Right. Now, events quite occur in real life that you want to know something after something has happened. So, this type of conditional probability will help you through the multiplication theorem to give you the desired outcome. So, now let me take here one more example. Suppose there is a student who is undecided to take whether a French course or a chemistry course. Well, this happens, and in these cases the student will always try to see that which of the course is going to give him or her a better grade. So, similarly the student also estimates his probability of receiving an A grade in chemistry and French course, and he finds that getting a grade A in the French course is 1/2 and in the chemistry course it is 2/3. So, now if the student decides to base his decision on the flip of a fair coin, that he says that okay, I will toss a coin, if it comes head then I will take this subject, if it comes tail then I will take this subjects. So, in case if the students decides to base his decision on the flip of a fair coin, then we want to know what is the probability that he gets an A in chemistry. Right. So, now you can see here that this event is going to be based on the outcome of another event of flipping a coin, whether the student gets a head or a tail. So, now let us try to define here two events. Let C be the event that the student takes chemistry and A is the event that he receives a grade A in whatever course he takes, either French or chemistry. Then in this case the desired probability what we want to know is the probability of C intersection A, that the person takes chemistry as well as he gets a grade A. So, this is calculated by using the multiplication theorem of probability, as probability of C intersection A is probability of C into probability of A event C, which is, and the probability of C is 1/2, this is given here, and probability of A given C is here like this. So, now this will come out to be here 1/3. So, now based on this there are nearly 33% chances that the student will get grade A in the chemistry. Now, let me try to take here one more example, and this example is related to the playing cards. So, we know that in the box of playing cards there are 52 cards, right. And suppose we try to make 4 piles of these cards and they are equal in number. So, every pile will have 13 cards each. Now, we want to compute the probability that each pile has exactly one ace. Ace, you know that in the cards there is a card with a symbol A. Now, we define an events say EI, say E1, E2, E3, E4 depending on different possibilities as follows. So, let even be the event that the ace of spade is in any one of the piles, even that the ace of spades and the ace of hearts are in different piles. E3 is the event that the aces of spades, hearts, diamonds are all in different piles. E4 is the event that 4 aces are in different piles. You know that in the playing cards we have different types of symbols, spades, heart, diamond, etc. So, that is related. So, now based on this we want to compute the probability that each pile has exactly one ace. So, that means we are interested in E1, probability of E1 intersection E2 intersection E3 intersection E4, right. So, now so this probability can be obtained using the multiplication theorem of probability as follows. Now, I can write down here probability of E1 intersection E2 intersection E3 intersection E4 as probability of E1 into probability of E2 which is condition on E1, probability of E3 which is condition on 2 events E1 and E2, and probability of E4 which is condition on 3 events E1, E2 and E3. Right. Now, I try to compute these probabilities based on the different numbers of cards in this group of cards. So, now the probability of E1 will be equal to 1. Why? Because if you try to see, you are trying to define here E1 as the event that ace of spade is in any one of the piles. So, definitely you are trying to divide all the cards into 4 piles. So, definitely it is going to be there in one of the pile. So, in this case the probability becomes here 1. Right. Now, the probability of E2 given E1, this will be 39 upon 51. Why? Because the pile containing the ace of spades will receive 12 of the remaining 51 cards, because you have total 52 cards and you want to, and you have a pile of 13 cards. And similarly, if you want to find out the probability of E3 given E1 E2, this will come out to be 26 upon 50, because the piles containing the aces of spades and heart will receive 24 out of the remaining 50 cards. And finally, this probability E4 given E1, E2, E3, this will be coming out to be 13 upon 49. So, now in case if you try to just substitute all these values over here, then we can find out the probability that each pile has exactly one ace. Probability of E1 intersection E2 intersection E3 intersection E4 as 39 upon 51 into 26 upon 50 into 13 upon 49, and obviously 1 into these things. So, this is 0.105 approximately. So, there is approximately a 10.5% chance that each pile will contain an ace. Right. Right. So, okay. So, now we come to an end to this short lecture. Well, this lecture was short and I have taken a very simple example to explain you. And I have taken a very simple result to explain you various types of probability that can be computed from it. But this is a very important result I am telling you. So, now as always, I will request you that you try to take some example from your assignment, from your books, and try to practice them. Once you have this practice that how to take a call, that where you have to found which type of probability and how are you going to find out these probabilities, that will help you a lot in the decision sciences or data sciences. And in data sciences, we have one more very popular approach. This is called Bayesian approach. And this Bayesian approach is mostly now based on computers. And because of computing only, this Bayesian analysis has become very popular. means after the advancements in the computing and computers. So, this theorem is going to help you a lot in case if you are trying to learn the Bayesian inference. So, with this aim you try to practice it, try to learn more, and I will see you in the next lecture. Till then, goodbye.